Okay, so here it is. Here's problem number 1. So we need to graph those for, let's start with graphing tangent x plus pi over 2. So let me go to a fresh sheet. I'll write those all down again, but question number 1, let me start with tangent x plus pi, that was the first one, right? Yeah. Tangent of x plus pi over 2. What is that graph going to look like? Well, again, remember that the original tangent has vertical asymptotes at negative pi over 2 and positive pi over 2, and he does a snake right in the middle in between the two vertical asymptotes. And it goes on forever, right? There's more snakes to the right and more snakes to the left forever. But I just want to find the one right in the middle, and the rest, just repeats. Y'all with me? Just how we handled the sine and cosine yesterday. We found one cycle, and after that, sine just keeps repeating to the right and left forever. Same thing for cosine. That's what all these graphs do, don't they? We just find the one in the middle, and then it just repeats right and left forever. So the same thing with a snake, just snakes forever, right and left. Okay, so the game plan I'm giving you is you take this inside, and you say, hey, when that inside is between negative pi over 2 and positive pi over 2, then you're at this spot and this spot. You're at the left and the right vertical lines, vertical asymptote lines. That's what we have to find. Is that making sense? Whenever the inside, whatever x values, whatever makes that inside become negative pi over 2 and positive pi over 2 gives you these vertical asymptote lines. Let me put it to you this way. You know what math and science is? Math and science is patterns. That's what it is. It's not memorization. That's why I give you 3x5 cards. Like, who cares about remembering things? What matters is patterns, learning how to deal well with patterns. So look at the pattern I'm giving you when I draw a tangent. When I put an x here, that could be a blank for all we care. That x is just holding a spot. Do you get the idea? And what we're saying is this is the what? This is the x-axis. So when I put x there, I mean that axis. So whenever on the x-axis you're at this spot or this spot, whenever the inside is positive pi over 2 or negative pi over 2, then you're going to have those vertical dotted lines. So this is what I'm doing. I'm taking the whole inside. This is like the whole inside now. I'm saying when the whole inside is negative pi over 2 or positive pi over 2, I'm going to have those two vertical dotted lines. So let's find it. All right, so how do we solve that thing? This is a three-parter, isn't it? Left, middle, right? How do I solve that? How do I get x alone? X is saying, I want to be alone. Get rid of this positive pi over 2 thing.
Negative pi over 2.
Good job. Subtract pi over 2, huh? And whatever you do to one part, you had no choice but to do that to all of them, huh? Good so far. That'll get rid of it in the center, and x will be alone. Is that good so far? Now I got to work out the left side and work out the right side. Here, let me do the right side first. What's pi over 2 minus pi over 2?
0.
That's 0, huh? That was easy. Now, how about the left side?
2 pi over 2 is negative. Because they're going to add, but then they're going to reduce.
Good. It's negative 1 pi over 2 and negative 1 more pi over 2. So it's negative 2 pi over 2, better known as negative pi. Everybody good there? See what I did? Negative 1 pi over 2 and negative 1 more pi over 2 is negative 2 pi over 2. Or 2's cancel, right? Just negative pi. We good there? Or if you want, minus half a pi is minus a whole pi. Okay, so what? What does all this mean? That means this is the new left edge. This is the new right edge. So when I go to do the graph, the actual it's not going to be at negative pi over 2 and positive pi over 2 anymore. It's going to go wider. It's going to be at negative pi and, oh, 0, huh? I went in the wrong place. What am I doing? Negative pi and 0. Right over here. So it shifted, didn't it? And what do you put in the middle? Right in the middle? You put the snake. There's the graph. And there's snakes forever to the right and left. And we're done with that one. Do you see how I found that? Yeah.
It says otherwise for the right answer on this.
It
says otherwise for the right answer on this, on the whole math Excel thing.
Okay, I'll look at the actual math Excel in a second.
Okay.
But are we good so far with what I've done up to this point? Is this making sense? What did I do? You take, whenever you have a tangent, so we're going to do all of our time together today is we'll grab the inside and say, hey, inside, you're between negative pi over 2 and positive pi over 2. Because that's where the two lines are for the tangent. That's where his two main lines are on the original. And you solve for x. I subtracted pi over 2 to get x alone. Do it from all three. You get negative pi and 0. That means it shifts. It grabs those dotted lines and it shifts the graph so that the snake is now between negative pi and 0. But the snakes go forever. So there's another one here and on it goes. Right? So let's look back at the multiple choice options now. And we want to find the one that has a snake between negative pi and 0. And by the way, is the snake going up or down? What do I mean? As you go left to right, it goes up, doesn't it? What would make it go down? What have we learned makes a graph turn upside down? Negative in the front. They'll do that in a minute. They'll put a negative right here in the front of the tangent, or a negative number like negative 2 or 3 or negative a half or whatever. When they put a negative in the front, that makes the graph turn upside down and go high to low instead of low to high. Huh? But ours right now is right side up. It's going low to high. Okay. So here's our picture again. Let's take a look. Let me try to be real clear. Look at it right here. Here's the snake. It gets close to 0, negative pi. It's hitting right there, halfway between negative pi and 0. Right? Does it hit the origin? No. There's the origin right there. 0, 0. It's not touching the origin. It's left of the origin going up. Let's go back and look. This one's not right. This one's hitting the origin. See the snake? It's hitting, can you tell the grid line? This is the y-axis. It's hitting right in the middle of the y-axis. That's not right. Maybe I'll draw a graph here if it helps. It's supposed to go from negative pi to 0 like that. Right? That's tangent of x plus pi over 2. So it's not number 1, is it? Number 1's in the wrong place. He has the snake sitting right in the middle of the y-axis. That's not right. The snake is left of the y-axis, huh? Y'all with me? How about number 2? Is number 2 correct? Number 2's it. Do you see it? Now, it's confusing because they're not showing the rest of the snake, but here it is over here. See how it's coming up right at 0? So that's the problem that makes these a little bit tricky. They only show part of the graph. The graph goes forever, right and left. All these graphs repeat their pattern forever, left and right. So the part you might have found, they might not show that part on the multiple choice option. You have to be able to tell which one's the same, even when they show you a different part of the same graph. Can you tell number 2 is the same? Mm-hmm. Because see how this part comes up here? Just to the left of the y-axis.
So it's showing the repeat part.
Yeah, it's showing this next branch, dotted line, and another one. Or start of another one. Yeah, it is. Everybody see that? Let's make sure. Why do we know it's not number 3? What's number 3 doing? Look. It's going down. Number 3 is going down, and so is number 4. Going down. So those are both negative. Those will be the two negative ones, these guys, that have negative in front of tangent, huh? They're going down. Everybody tracking with me? So it's number 2. So this goes with number 2. So I think it has you drag and drop, doesn't it, on the homework? So drag that into number 2. We good there so far? This making sense? And so, if we're continuing to use comparison, what about negative tangent? That's got to be one of those that's upside down, huh? It's going down. It's got to be 3 or 4 because those go down. Those go down. How do you know which one it is? Well, nothing else has been shifted about it. So it's going to have the same two dotted lines. You tracking with me? When you just have an x here, and you don't have like x plus pi or x minus pi over 2 or whatever, just have x, that means the dotted lines aren't going to move.
So it's going to cross the axis, or cross the...
So the dotted lines will be the same as what they always are. What are they originally? Negative pi over 2 and positive pi over 2. You tracking with me on that? So for number 1 here, see how it is going with 3. Negative pi over 2. Wait, no, not 3.
4.
I think it's 4. Yep. See how it's going with number 4? Why? Because it's the dotted line. See the dotted line here and the dotted line here? Where's it at? Negative pi over 2 and positive pi over 2. The normal place where the dotted lines are on a tangent where it's not been moved at all. We good there? Is that making sense? Do you see why I say that one has not been moved? Maybe I'm not making sense on that. Let me try that one. If you take minus tangent, what are you supposed to do? You're supposed to take the inside and put the inside between negative pi over 2 and positive pi over 2, and then solve for x, but x is already alone. There's nothing to do. So that's saying it's going to be between negative pi over 2 and pi over 2. Are you with me? Right? This is how we do these problems. We always take the inside, whatever's being put in the toaster, is how I say, just to make you think about plugging in. That's what we're doing with all these trig functions, sine, cosine, tangent, whatever. So the x is plugged in. You're supposed to take the inside, in this case it's just x, and put it between negative pi over 2 and positive pi over 2, and then get x alone, but it already is alone. In this case, there's nothing more to do. So the two vertical lines are going to be where they originally started. Negative pi over 2 and positive pi over 2, which means it's this one. Because that has the vertical lines at negative pi over 2 and positive pi over 2, if you can see that barely. And the snake going down to the right, because it's negative tangent. Are we good? Or are we feeling totally confused? So we've done the first two. Good, let's do the last two. So I'm going to do, well actually you can match those up now, can't you? Pretty easy. Right? Number 3 is the other one that's going down. What is the other one that's going down?
It's going to match pretty much the first one that we did.
Yeah, it's number 3, going down, yeah. If you mess with the inside it would, you're right. And number 4 is the other one that's going up. Which is that one, huh? Do you see that? Because this tangent graph goes up to the right, and that's a positive in front of that tangent, up to the right, whereas the third one listed was a negative in front, goes to number 3. So they're going down. How we doing? I'm trying to read your faces. I feel like we're playing poker. I'm not sure.
I think these ones are easier.
Do you got a hand, or are you just bluffing? Can I help? Do you want me to talk more about these? So one more time. So first off, 2 of the tangent ones go up. Right? Number 1 goes up to the right. Number 2 goes up as you go to the right. We're always moving to the right in math. Imagine a roller coaster, right? You're moving from here to here to here. You're going up to the right. See that? Well, that graph's going up to the right. And then number 3 is going down to the right. And number 4 is going down to the right. So 3 and 4 have to be the 2 negative tangents.
We always read left to right anyway.
Yeah, at least in America.
Right.
So good. There are 3. So the 3 and the 4, the graphs are going down to the right. So it's got to be the 2 negative tangent. That's what made it go down. And then how we knew which is which is this one had just a normal x inside, so there was no shifting of his dotted lines. They were negative pi over 2 and pi over 2 like the normal original tangent. So the second equation goes with the fourth graph, therefore. All right, let's try some more. Okay, so they're giving me 1/6 tangent 6x. They want me to say which of those graphs, multiple choice, is the right graph. So what are we supposed to do? It's all about finding those two vertical lines. Let me go to well, no, we can do it here. So you grab the inside and you say, hey, inside, which is the 6x, you have to be between negative pi over 2 and positive pi over 2. So I grab the inside and put it in there. So 6x is between negative pi over 2 and positive pi over 2. Everybody good to there? So now, can you solve that for x? Can you get x alone then? So how do we get x alone there? What do we do?
Divide 6.
Yeah, divide 6, right? So whenever, we're going to do a lot of getting x alone on these today. So whenever we get x alone, we always do the opposite of whatever's there with x. You comfortable with that? So it's 6 times x, multiplied by x, so the opposites divide. Now, let me show you an easier way to divide when you have fractions involved to make things a little smoother. I could divide. Don't write this down. This is true, but not the easiest thing. That's true, right? You'd have to divide all of them by 6, wouldn't you? Whatever you do to one part, you have to do to all 3 parts. You have to divide them all by 6. That's okay. That's true. That's right. It's a little difficult. What would you have to do with this 6 over here? This is kind of awkward looking right there. You know, a fraction over 6. Although we've done it before. We did it last week, right? What do you have to do? Flip it, right? The 6 on the bottom, 6 over 1, flips up, become 1 over 6. That's totally fine and good and right and true. If you do that, you get the right answer. But let me make it a little easier. When you go back and you're looking at this and you're thinking, okay, I need to divide by 6, that's true, to get x alone, right? But then you look right and left and you say, oh, but I got fractions. I don't want to divide a fraction by something. I got fractions over numbers, it's a little messy. What you could do, instead of dividing by 6, how could you get that x alone, get rid of that 6 that's in front of it, by multiplying? What could you multiply that's going to have the same effect as divided by 6? Yeah, 1 over 6, huh? Because this is 6 over 1 and they'll cross cancel. Does that make sense? Why do I do that? Well, because then that's easier to do with the other two since they're already fractions. Just multiply everybody, left, middle, and right, by 1/6 instead of dividing by 6. It'll make your work a little easier. It's the same effect as dividing, isn't it?
You're skipping a step.
Kind of like, yeah, skipping the flip it up, huh? It's like we're already at the flip it up step, right? See how that's easier? Instead of dividing by 6, multiply by 1 over 6. That's the same effect, right? Because multiplying by the upside down is dividing, isn't it? So what happens? I get x alone in the middle. And the other side I get pi over 12. And back here I get minus pi over 12. Minus pi over 12 and regular pi over 12.
Well, yeah, I was thinking, well, because you know, you just divided by 6. Will that be a different answer then if you would have did it the other way? Let's say.
Yeah, no, it's same answer. Yeah, good question though, Clarence. Let me do it.
Reciprocal, it's like,
yeah, so it'd be pi over 2 divide by 6, huh? That was the other way. Yeah, Clarence's question is, would it really come out the same? It's a good question. Let's try it. Pi over 2 divided by 6. This would be 6 over 1. Any whole number is really over 1. Grab it and do what? Flip it up and it becomes 1/6 and you multiply. It's gone from here. Be pi over 12. See? Yeah, whenever it goes up, it has to flip. Why? Because dividing is upside down multiplying. So you got to multiply by the upside down. Yeah, that's another way to get the same answer. But we were able to skip the flip it up step this way. So just multiply by 1 over 6, 1 over 6, 1 over 6. That has a dividing effect. Okay, so where are we at now? So that means what did we just do? That means this is the left, negative pi over 12, and this is the right, positive pi over 12, dotted lines. We found the left and the right dotted vertical asymptote lines. So that means the real graph, the true answer, is going to have dotted lines at minus pi over 12 and positive pi over 12. And in between, it'll have a snake right in the middle. So that's going to have to hit the origin, isn't it? Because that's right in the middle of negative pi over 12 and positive pi over 12. 0.
But what's the 1/6 in front?
Oh, good question. It'll almost do nothing. I'll explain why in just a second. But pretty much it'll look just like that. I'll explain why. But is everybody good to that point? Everybody good with finding those two vertical asymptote lines, putting them on the graph, knowing it's a snake in the middle? Is that making sense how I'm doing that? What did I do? I take the inside and I put it between negative pi over 2 and positive pi over 2 because that's where the normal, unaltered, original tangent lines are. Get x alone. X has got to be between minus pi over 12 and positive pi over 12. So I put that down, got the snake graph. Yeah, now what about that 1/6? What's that going to do? Well, that 1/6 will multiply all the heights by a sixth. So it'll take this snake graph and kind of compress it down so it's 1/6 as tall as it used to be. But you won't be able to see it much in the end because how high does this graph, does the snake go right now? How high does the snake graph go, tangent graph? How high does any tangent snake go? Infinity. It's going up, 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 up and away, isn't it? So it goes to infinity, up and then down also to negative infinity. So because it goes up forever, it's just going to go slower. 1/6. It's going at one. It's going to go up forever, but at 1/6 of the speed. So the difference would be it's scrunched down a little bit. So it kind of goes slower and then up, slower and then down. But in the end, you won't be able to see much of a visual difference since it's going up to forever anyway. It just gets there slower.
Okay, so it's just there to confuse us.
It's kind of like that. You know, that's really the difference between different people's income. You ever thought about it that way? We make this big deal about getting better paying jobs and stuff. But really, it's just a rate at which it happens, right?
Yeah,
If,
like the same.
right,
We just
it's just a
get
matter
there
of time, right? You know, if the big businessman, I don't know what Bill Gates makes, millions of dollars a week, I'll make $1 million eventually, right? You know, minimum wage job will pay $1 million eventually. Just a matter of time. All right, just the rate at which it comes in, huh? So minus pi over 12 and positive pi over 12, we got the snake in between there. So which one of the graphs does that?
C.
Isn't C going down?
I mean, B, sorry.
B, yeah. Yeah, C is almost right, but C goes down. See how the C goes down? So that would be a negative in front of the tangent, huh? So it's not C, it's B.
It was C on my screen.
On your screen, huh? Yeah, shifts them around. See how it's B? So everybody can see how the snake is right here between negative pi over 12. Hits right in the center at the origin. What's wrong with A? Why is A not the answer?
Shifted.
Yeah, it's not hitting. See where it hits right here? It's not right on the origin. The snake is always in the middle of his two lines. Oh, and he doesn't have it dotted at pi over 12. He has it a little bit to the right. Yeah. So A's not right. C's not right because they're going down. So the answer is B. How we doing? Is that good? Okay, I'm going to move on. So we have a left, middle, right there. And X in the middle is saying, I want to be alone. So can you get that X alone? Give you a second there. So what do you got to do to get X alone? Remember, we always do the opposite of whatever's going on with X. What's going on with X? X is having pi over 5 added to it. So what will I do to get X alone? Subtract the pi over 5, right? And whatever you do to one part, you've got to do to all three, don't you, to keep the balance. Left, middle, right. Everybody good? So these cancel, and we have x in the middle. We get x alone. So how do we, on the right side, how do we take pi over 2 minus pi over 5?
To make a common denominator.
Yeah, with fractions added and subtracted, we got to make common denominators, don't we? So let's do it. So that means multiply top and bottom of this one by 5, top of that one by 2. So we get 5 pi over 10 minus 2 pi over 10 is 3 pi over 10. Everybody good there? And then on the left side, it's going to be same thing. Multiply top and bottom of this one by 5. Top and bottom of this one by 2. We'll get minus 5 pi over 10 and minus 2 pi over 10. And that makes minus 7 pi over 10. And those are going to be where the new vertical lines are, right? The vertical asymptote lines, the dotted lines. That's where they're going to be. Notice they're different amounts. Which one is further from the center? -7 or +3? -7. That's 7/10 back. 7/10 pi back. That's only 3/10 forward. So the graph is going to be more left than right. Do you see that? When you go to make the dotted lines, the left one is further left. So this one's not centered on the axis like the last few have been. It's going to be off center, isn't it? Do you see that? So go ahead and see if you can draw those two dotted lines and see if you can do the graph. I'll go there too. So we found negative (7 pi over 10) and positive 3 pi over 10. And so when we go to the actual graph, I'm going to go pretty far left. -7 pi over 10, and then just a little ways right, positive 3 pi over 10, and put a snake in the middle. Like that. Now the snake is right in the middle of those two lines, which is not at the origin. Huh? Everybody seeing that? I don't really care where it is. You don't have to find that point. Just it's not at the origin. You just got to do the best graph you can to answer the multiple choice options. So can you tell now which of those it is? What's wrong with B and C right away?
They're negative.
B and C are going down, aren't they? Do you see that? Do you see how B graph goes down to the right, C the graphs go down to the right? That would be if you had a negative in front of the tangent. We're going to have one of those in a minute. If you had a negative in front of the tangent, like any graph, you have a negative in the front, turns it upside down. That's not right. So it's not B. It's not C. Could it be D? D's going up. That's good. And I'm seeing negative, I know you can't see it very well, but I'm seeing -7 pi over 10 and 3 pi over 10 like we've got. But do you see how it's not, the snake is not in the middle?
It's not centered.
The snake's right here. Yeah, it's not centered. It hits like right there, really close. It's like hitting way over here, really close to the -7 pi over 10, isn't it? So that's not right. The snake has to hit right in the middle of the two dotted lines. So it's A. See how A is correct? See how it's hitting right in the middle of the two dotted lines? So A it is. How are we doing? This okay?
So
Questions?
we don't really need to know like this.
Ani.
Yeah.
Sorry, I'm always practicing, yeah.
We don't really need to know like the specific numbers in between the boundaries. Is that like
Yeah, you don't need to find. Yeah, all you got to find is the two dotted lines.
okay?
Yeah, that's all we need. Yeah, they're going to keep this pretty simple. You know how yesterday with sine and cosine, like we got really specific, right? We found out exactly, where things were as far as when the height, how high it went. We moved graphs up and all that. They're not going to get that specific. They're going to keep it more general because there's 4 of them, and you honestly, if you're going forward in pre-calc calc, you mainly use sine and cosine. You hardly ever graph these 4 graphs: tangent, cotangent, secant, and cosecant that we're doing today. It's really rare. Every now and then one of those will come up, but pretty rare. Sine and cosine all the time. So that's why they did a more thorough job on sine and cosine. Expected us to know amplitude, period, phase shift, and the vertical shift, and all those specifics. They're not going to be like that. For these graphs today, it's all going to be find the 2 dotted lines, put the thing in the middle. Done. That's pretty much going to be what I'm going to show you for all the other ones too. Find the 2 dotted lines, put the thing in the middle. That's going to be all. That's all you need to know in general, because it doesn't come up much in the future. They're just getting you ready for what you need to know in the future. Shift. So let me draw you the graphs here. So here, let me put tangent up one more time, real quick. Whoops, kind of getting off kilter there. So negative pi over 2, positive over 2, tangent. Does that. So there's tangent again one more time. Okay, now what is cotan going to do? So come on over for cotan. Whoops, squeeze that over a little bit better. So cotan is going to go from 0 to pi. So first off, cotan has the vertical dotted lines shifted a bit. Remember what the word co means in front of a trig function? Complementary, 90-degree shift. Complementary angles make 90 degrees. Remember we talked about that, I think, last week. Sorry. Last week we talked about why half the functions are called cosine, cotangent, cosecant. It's because it's a 90-degree shift from the other ones. And here we're starting to see that. See how cotangent is a 90-degree shift sideways from tangent? Why do I keep saying 90? What's pi over 2? Remember pi is 180? 180 over 2? 90. That's 90. What's pi? What's just straight pi? 180. So the right edge went from 90 to what? To 180. It went right 90 degrees, didn't it? Cotangent. Complementary angles. That's it. That's why all these cofunctions. That's why they named them that way. They're saying to us, these are just 90-degree shifts off the originals. That's like sine and cosine. They're just a shift, as we saw yesterday, off each other. So anyway, so cotangent, it just shifts the 2 dotted lines to 0 and pi. You'll have that on your 3x5 card next Monday for the exam. So you just go. Cotan. Now, here's one other thing. Not only does it do that, but cotan is the what? Upside down of tangent, right? The reciprocal function, the flip. So guess what's going to happen to the snake?
Go down.
It's going to go down instead of up. It's going to be right in the middle, going down instead of up. Down to the right. I always mean as we go to the right. Down to the right instead of up. So if you stick a negative, that's cotan. So if you stick a negative in front of cotan, then he'll look like tangent, won't he? Although he'll still be different dotted lines. But if you put a negative in front of him, he'll flip up like tangent, but he'll have 2 different dotted lines nevertheless. There's cotan.
So is the formula still the same?
Still the same.
With 0.
Just with 0 and pi. That's how all these are today. This is easy. I find you can find this section pretty easy. It's just we're going to take the inside, but instead of negative pi, put it between negative pi over 2 and pi over 2, we'll put it between 0 and pi. And then when we draw the snake, we'll draw him down. Unless there's a negative in front, then we'll draw him up. It's the same. It's not going to be much different with the other 2.
On the left and pi's on the right.
Yep. Exactly. So let's. Okay, so here's number 4. They're giving us the graphs. So I am going to match them up. So let's see. Let's start with, notice 2 of them are negative and 2 of them are positive, right? See how we got 2 negative cotangents up there and 2 positive? See how, here, let me highlight them for you. See how this guy's negative and this guy's negative? Negative in front, negative in front. See how those 2 have negatives in front? So normally, cotan goes down because he's the upside. So these 2 have to be the ones going up. So, which is what? This 13 goes up and 14 goes up. 15 and 16 go down, don't they? Down. Down. So basically those two with the negatives have to be 13 and 14. How do we know which is which?
Well, the first one doesn't have anything added.
No
to it.
shifts.
There's no, yeah.
Yeah.
It would go between 0 and
It's going to do what cotan normally does, which is number 13 there, huh? Everybody see that? Because why? Where's his dotted line? Oh, by the way, there is a dotted line right here. You can't see it because the axis, the vertical axis, the y-axis, is overshadowing it. How do I know it's there then? Well, because the graph hugs that line, That's always a vertical asymptote. Whenever the graph gets in, that's what those lines do. It's a line of approach, a guideline. A line the graph gets closer to forever. It guides the graph on up or down. Yeah, Jose?
How do you know which one's going up and down? I mean, you have the arrow, the snake of the arrow is going in both directions.
As you go to the right. Great question. It's always, yeah. It'd be like if I said, hey, here's a mountain, here's the side of it. Is that mountain going up or down? Well, you can go up and down on a mountain. Depends which way you're going. Your question is great. So therefore, we have to pick a side. It's always as you go to the right. So in math, we always mean as you go to the right, are you going up or down? Yeah, because otherwise, every mountain goes up and down. Every line goes up and down. So as you go, yeah, so this one, see, as I go to the right, I'm going up on that one. As I go to the right, I'm going up. Whereas this one, as I go to the right, I'm going down. See, down to the right. Down to the right. Yeah, this arrow can fool you like, hey, no, that's going up. That's the wrong direction. That's left. As you go to the right, it's going down. Yeah, watch out for their arrows. They're not trying to fool you. They're just drawing the graph. But that arrow can fool you. Right? We always mean as you go to the right. If the roller coaster's going this way, we're going down. It's as you move to the right. Good question. Yeah, so everybody see this first one is the negative cotan because his two dotted lines are at 0 and pi. It's hard to see the 0 and pi, but you can see pi over 2 is in the middle. So that must be 0 and pi. So therefore, the other one, 14 must be the other negative cotan because that's going up. So now we've got 15 and 16, the two cotans that are doing what cotan normally does, going down, they've got to be the two in the middle. The two equations, formulas in the middle. Which is which? Well, let's go figure it out. Let me grab, say, this one and go to a fresh screen. Okay. Yeah.